experience when you increase the level of complexity of the task, then you're obliged to have some shared levels of control in your let's say solution, because I think pushing shared control to perform simple tasks is an overkill. Sometimes we see papers, sometimes we see applications that people use shared control, really sophisticated shared control approaches for very simplistic tasks that can be 3 lines of code for an autonomous robot. I think it's important also to understand the context and to match what control and what type of control fits the best the action. I think by increasing the complexity, then shared control at the moment, unfortunately, it becomes inevitable. But maybe by augmenting the autonomy of the systems in future, we will move more towards, variable autonomy, and this will go more towards autonomous systems than let's say the requirement for a human operator.
Yeah, complementing Arash, also when the complexity of the robot increases. So for example, when you want to control, now it's possible to control multiple robots at a time. And of course, a single operator cannot control all the robots. So it's very important that the system manage to do something by its own.
Yeah, and also sometimes if you really want to control the human side, then shared control probably is the only way out of the wood, because you cannot neglect something that you want to control by means of another entity. So that's basically, sometimes it's a necessity. Let's say this.
So you mean also influence the human in his behavior, if you can?
Yes, sure, absolutely. You can. I mean, what I dream is that we can model also the psychological state of the human, and we put them as a set of equations. And so you have the floating base system for the robots, the floating base system for the human. You put I'm happy now if someone is going to read the project. So you treat everything on a single equation. So this is what I dream of, is that also the psychological state of the human.
There is so one thing that I was thinking about so when at some point in his presentation, Paolo Robuffo Giordano was showing the teleoperation of the DLR robot with a big system, with the bimanual system, and the operator was looking at the robot, no? Yeah. So I imagine that it was like a DLR operator, so maybe like comfortable with the robot. But imagine if you were teleoperating this, and you know that you know how much it costs the robot that you are teleoperating, the level of stress that you put on the operator. So yes. If it would be like a normal guy, I mean, and also like maybe like sharing like the cognitive load. I think there was an intervention by Arash at some point was telling something in this sense.
Yes, I think, there's, if I can add something on this, when we're trying to provide a solution which is going to be used by humans or shared by the humans in performing a task, I think it's really important to also, sometimes we get nervous when we receive comments from reviewers saying that, but did you do any subjective analysis? Did you really ask the people if it works? Sometimes we come up with the best passivity teleoperation systems, multi-channel, let's say, bilateral teleoperation systems, or human-robot interaction, super fancy. But at the end of the day, we don't really measure how cognitively, let's say, engaging or how physically engaging this is. And unfortunately, as also Daniele mentioned, at the moment, we don't have correct means of measuring the cognitive load. And we have these really simple subjective, qualitative tests, like, are you happy? And what we do is just go around the lab, ask a few students. They're sometimes afraid to tell us the correct answers, basically. Yes, you're already biased, because I think these studies should be really moving towards realistic applications, real use cases. If you're talking about human-robot collaboration in industry, we really need to test them on real workers, have no clue about how the kinematics and dynamics of the systems are, and in teleoperation with real space applications, surgery, and things like that. we cannot really provide solutions if we are not going to use it. If you have the supercomputer with 1 million keys, that each key does a fantastic job, but if you're not happy to use it, you're not going to use it.
Yeah, the problem is that there are tools for measuring like the cognitive load, and these are like, for example, the pupil measuring the with eye trackers, or there are like skin conductance sensors, or EEG. So I've seen many tools, but these are like okay for lab studies, but the subject has to be still. Don't move, focus on in front of the robot. So it's not applicable to real world conditions. So if you want to bring this kind of measure in, for example, on a workshop, in an industry, on a work floor, it's not feasible. So these measures are not possible. They cannot be used. So there is a problem in measurements, and I think also a problem in like feedback channels.
We made some experiments in that. So we're working on wearable devices for evaluating the level of stress, and you can do it online. But the thing is that these things like stress, for example, have a very slow dynamics. So you can add a state taking into account the level of stress of the operator into your model, but basically the job time is much smaller than the time necessary to become really stressed. So maybe the tool we are using.
So what do you use for, as curiosity? You use skin conductivity sensor?
We're using the smartwatch heartbeat sensor. So the variation of the heartbeat rate is a measurement of stress. So it's related to the stress.
The problem is that this measurement is too dependent on many conditions, like if you are if the temperature, if it's humid or not, if you had coffee before, then your cardiac frequency is something else. So it's too sensitive. It's very sensitive. We had a discussion about this with a cardiologist very recently. So I discovered, for example, that if you do the same experiment, like before or after lunch, your cardiac frequency is completely different. So now I have to add this condition also to my next experimental protocol. Like,
don't drink coffee.
Please don't drink coffee, don't drink tea, and only experiments in the morning.
Serena, for this, I mean, we are trying to build this system that we call I feel emo. I know that you don't like, but just to retrieve psychological quantities. And what I believe is that for the time being, we have to feel it with sensors, a lot of sensors. Then we will understand how to come out from the wood. So that's for the time being. I mean, one of the approaches that we would like to take. We take the suit, we put it with a lot of integrated sensors, and then we will try to understand what correlates with what.
The problem is that this is still, I think it's okay for lab studies, but if you go on an
you're right. No, you're right. You're completely right.
You may use the suit for understanding, and once you understood, you get back and try to use.
I think we need to really have some as Serena mentioned, we need to really put some realistic applications in front of us. For instance, this pupil case, there are numerous papers about that if the size of pupil goes high or low, it directly associates with the cognitive. But imagine a series of industrial tasks that you're moving from point A to B, and the illumination and lighting condition changes, and you're directly associating to the stress, which is not correct. And you've spent a lot of time to optimize this algorithm, provide the best solutions, and then you arrive to the last point and say, it didn't work. Now let's go back 10 years of research to understand how this works. I think there should be a connection. I am myself part of the bottom-up research, but sometimes, especially when it comes to application, we need to look from the application and propagate some ideas towards the basic research. That could be, I mean, some trade-off at least needs to be done, if you agree.
No, I mean, on this I agree. What I would avoid to do is to reduce the number of sensors without understanding the fundamental principles. So because I mean, I would reduce it after I have understood. So probably one approach could be, let's replicate one of the use cases in the lab, like you were saying, in these industrial applications where the lights go up and down, and then you put a lot of sensors and you understand. Once you understand, you can probably, I don't know, make the work of reducing the sensors or understanding better what is the solutions for the environment towards which you conceive these solutions.
If I may add something, like maybe I can do some publicity about the workplace where I am now. Actually, this is what we do here. Like Steve Laval built a group that is hinged on perceptual engineering, that is basically between psychology and engineering. And he's trying, I mean, the final goal is to do what Daniele was doing, like try to find a minimal set of sensors that can be used on a human in order to do some, let's say, experiments on normal people. So not assuming any kind of pre-knowledge about people. And actually we found out that it's very easy to bias people in general. Even like for the suit, like if people tries a suit that never tried before, they become nervous, and the kind of reply is completely different with respect to if you don't make any suit. So let's make just sort of publicity. So if you're interested in this kind of stuff, I mean, you can contact me anytime, and I will be more than happy to discuss about this stuff, because it's kind of core of the lab now. So.
No, yes, indeed, we can get connected offline, yeah, sure, and speak privately. No, indeed, yeah, would be really happy. We are newbies in this. We're just starting. We are building technology, so yeah, it's a lot of long journey to do.
Nice.
Marco, you should tell us if what we are interested in is observable or not, basically. So.
Sorry, can you repeat?
You have to tell us if what we are interested in, measuring the stress of a human operator controlling a robot, is observable or not, and how.
Yeah. I mean, I will. I mean, at some point, I will tell you that.
I think. I mean, we've been looking also into. Sometimes we're looking into the consequences of an action. Maybe sometimes the source cannot be measured, for instance, or all these sensor systems that you have to measure the cognitive load is not directly measurable, but sometimes you can actually associate it to the main sources or the consequences. The main sources can be like the delay of the robot in responding to you. For instance, in a teleoperation case, if you have a delay in the loop, and the more the delay goes, and then this will create, let's say, some cognitive load, and you can actually measure those consequences. And also the response would be also something measurable. Number of mistakes, number of errors people do, or number of pauses that the person takes, or the delays of our system to respond to some actions. These are measurable systems, and we can easily measure them without any need for measurable units. Sorry, that we can actually associate it to cognitive loading, boredom, or things like that. We've been looking into this, but still, there's no guarantee that all these will work also in the real work case, in the real workplace.
So I have another provocative question. So when you think about autonomous cars, for example, I was in touch with many in many focus group. I heard I heard people from, let's say, general public, not engineers or roboticists, saying that they would still like to be in control of the autonomous car. So in that case, because of, I don't know, problem with trusting the machine, or just because they want to be feeling in control of the machine, so delegating the intelligence and whatever. So in that case, this, I think it poses a question about moving the limit between autonomy and shared autonomy. Or maybe not having autonomy at all, or having something autonomous, but that gives to the human the illusion that is in control. So I don't know if you have comments on that.
I don't know. I am losing expectation about this autonomous stuff. It's not, in my opinion, it's not going to be my lifetime problem. Let's say this. I'm gonna be dead when this. I have this feeling, but I agree with you. So either the human should be in control, or it should be a complete control environment, in my opinion, where we let completely give control. For instance, think of automated trains, no? So in that case, the environment is a sort of controlled. The trains can go only on that path, only on that path. So in these situations, you are fine in giving out control. Okay, already airplanes, you know that there are humans, the environment is not controlled. Okay, so if you create, I don't know, highways in the future could be only reserved by autonomous cars, where you basically have railways for cars, the analogous of trains, which is more or less what Elon Musk at a certain point wanted to do with underground highways, where you create your own environment and you define the rules and you remove the humans from the equations, and so you're fine in giving out control. So in this paradox, humans are fine when humans are not in the loop at all. So this is by large. This is my.
But do you think the same should be applied also? Like, I mean, for cars, we do understand, because we are used to have full control of the car, or full control, more or less, but let's say full control of the car. And so the opposite, which is an autonomous car, so a shared control approach would be probably more acceptable as intermediate step, unless, of course, it's an entire new environment where everything is like a big system. But do you think this reasoning could apply also to mobile robots, like mobile cobots, or like human, even to the up to humanoids? Let's say mobile robots with arms up to humanoids. So to never give them full autonomy.
So let me rephrase this question and ask you another question. So imagine you're using this shared video platform like Netflix or Amazon Prime or whatever, right? So you prefer these platforms to pick a video, to pick a movie or TV series for you and go directly and show it for you, depending on your experience and and these let's say research experience, or to provide you with some options, and in the end you will be the one to choose or not.
This I prefer. I choose. I still choose.
Of course. So my idea is, when it comes to robotics as well, I think we need to have a lot of choices, and I think robotics, until it will be appearing as smart hammers, like these systems that we know that they are under our control, but they're smart enough to make our lives easier, providing us solutions that, if I want to reach to that solution, I will lose energy, time, and a lot of waste associated to that. As long as this is the case, I think we will be happy. For instance, if an autonomous driving car tells me that this road is faster, the way that Google Map is doing, I will definitely try and select it based on my own reasoning. But if the autonomous driving car starts moving in that direction already without acknowledging what is happening, I think this will make me nervous. I think up to that point we can play, but then from that point on, we need to really be careful about the machine intelligence.
Yeah, but this is raising a point of also like mutual understanding, having the same level of information, sharing the information. Like if the robot in the case you make is sharing with you the plan, so I want to go there and this is the plan, are you okay with that? He's sharing with you his strategy, his policies, trajectory, etc. And so you can validate and say, okay, I trust you, let's go. But it's very easy with cars, because cars, you see, they move like in 2D. It's basically a 2D path. But with robots in a 3D environment, or 6D, because if you put the orientation of or even more, it's very difficult.
I think it's better to not have 6D, because one means flipping the car.
But in my opinion, the thing we should look for in robotics is not this master-slave paradigm, right? Like either the human choose or the robot choose. It's cooperation at the end of the day. So it's shared control. So at the end of the day, if the robot can do something in one way, well, the human should adapt to the robot. It's not always true that the robot should adapt to the human. So if we're working together, both the actors should influence each other. Perhaps it's similar to what Daniele was saying before. So it's a sort of the human influences the robot behavior, but also the robot should influence the human behavior in order to be efficient, to be likable, to be, yeah, to have a pleasant collaboration, I would say.
Mm. Yeah, on the long term.
Yeah, like yeah, in the long term, probably systems. I was thinking of the corrector when you write. Probably it's too far, but when you write English, you know, you're fine, and you have this underline when you are wrong. Okay, so if you scale it up to a robot, a humanoid robot here, it's like an assistant that really doesn't take actions, but it just correcting you. So it monitors you and it corrects you, but it doesn't really take action. So probably in this kind of relationship, there would be a confidence in the system, because you know that it's partially active, and if it does something, it's to correct you, not to do something you wouldn't expect.
But we have a question, a provocative question from Slack, and the question is: the next virtual ICRA, is it in teleoperation or just just on Zoom?
To finally have it in teleoperation.
Okay, it was by Antonio Franchi. Let's mention.
We expected it. So, but let me ask, I mean, I have another provocative question. I think we are talking about shared autonomy, but frankly speaking, I think one of the moments that we really needed simple teleoperation robots was last few months, that we could use them to test tampon tests on patients, to receive them to do temperature monitoring and things like that. Very simple, fully manual teleoperation. We don't even have those systems in a high TRL level that we can expose and we can exploit them. You know, the thing is, unfortunately, sometimes we really look at the end of the road, that we are not, you know, we are not able to pick these fruits that are, you know, reachable.
But you know that so because since we are doing teleoperation in my lab, we started to investigate if it was possible to do this tampon. I don't know, take the nose swab. It's really not, so I don't know if I would do that so even on me, I would not do it, because it's very invasive. So you have to take the stick and go very, very up. It's kind of painful, and you have to also keep the head in a certain way, otherwise you take the sample in the wrong part. So we had a sort of not like a pilot, but we discussed and showed some things to a doctor, and she was saying no. Take the temperature. Yes, we put the temperature sensor. It was doable. We also took the thing for respirating, for the breathing, but they were saying no, it's not what we need. So the feedback I had from the doctors, they were saying we don't need more robots in this case. We need more nurses, because they are able to look at more things.
I want to also be a little bit provocative here in the line of Arash. Okay, so I was also really frustrated. Okay, so I had the guy coming from Basco, bringing food to my neighborhood, and I thought, come on, we don't even have a robot with wheels that brings stuff from the truck to the apartment. Okay, and come on, at the end of the day, I was 15. I was doing self-driving cars automatically. Okay, so I have been studying 15 years, and we couldn't come up with this. There's something wrong in the process. Okay, so in this direction, to be provocative, what I think is that robotics is somehow missing the big occasions. Okay, so Fukushima, at the end of the day, we were not really there. Now another disaster appeared. Robotics, well, it's not there. In my opinion, one of the main problems is that we confuse the high TRL with low reproducibility, which is a fundamental concept in science. So you can be at low TRL, but your stuff should be reproducible, which is the foundation for increasing the TRL. And coming back again, in the root of all evil, probably that's the publish or perish thing.
Oh,
Because so the fundamental failures probably are connected to the fundamental problems that the community has. And having so low reproducibility, which is another thing of having low TRL, is something which is pushed by the publish or perish, because we don't care. Okay, you hear people, it works once out of 10, I publish the paper. And that, in my opinion, that is what led to our failures. And what I hope is that we take a moment now, we say, what did we do wrong? What do we want to do different from what we have been doing so far? Do we want to do the same things that we were doing before, exactly in the same way? Well, of course, yes, we can. Absolutely. It's a free word. But in my opinion, we would miss an occasion, a turning point. So that's my provocative statement.
So if I can add something on this, I don't think it's only our fault. I don't think it's only fault of roboticists, let's say. It's also the fact that you don't have high TRL products because the market doesn't require it. So we have seen this pandemic that exploded, let's say, in a very short time, in very rapid time. So we were not there. But I think if the market requires products, we have the way to make it.
No, but Mario, market was there for COVID, market was there for the Fukushima, but we were not ready. And I really agree with what Daniele said, also what everybody else said. I think sometimes, for instance, when you write teleoperation papers, like some comments come back as if they are telling you that the teleoperation is a solved problem, and you're doing research on teleoperation, and basically you're wasting your time. Same goes with grasping. If you do grasping now, people will just say, look, grasping is a solved problem. You're doing internal force control. Teleoperation of force feedback, it is solved problem because 60 years we are doing teleoperation. Yes, but show me one of those teleoperation systems that worked really, not in our fancy videos that we want to say robotics is helping COVID, in the hospitals, in Fukushima, in, I don't know, in a fruit shop grasping fruits. No. And I think there's a reason for that. And we being really, getting used to seeing a couple of lines about something, seeing a video. And I really agree, there's a lot of good movements on making reproducible results. And I think this is a very important topic, as well as producing really innovative, groundbreaking results. And we need to push both of them at the same time. It cannot be like, yes, we solved this problem, so we put it ahead. Why don't we see these robots in action? Collaborative robots. How many collaborative robots do you know that they are doing collaborative actions in industry? They are doing pick and place, but we don't have cage for them. So it's not what actually we were supposed to do, right? Because,
I mean, on this I agree. I completely agree. Sometimes they say, no, teleoperation is over. Okay, please show me where it works.
Exactly, yes.
Please, and show me 10 times in a row, not once. Exactly. Show me 10 times in a row. Okay,
I would
which
add
is
also,
reproducibility.
Show me with a setup that costs less than 10K, because to cook arms for teleoperating, grazie, ma 100K of teleoperation, it's not very affordable and scalable.
Yeah, nobody buys it. Yes, of course.
So you can do it because I mean, I really like those works, but when I see the price of optic haptic arms for teleoperation, like 6 DOF haptic arms.
80,000.
It's expensive. You cannot teleoperate. I mean, you cannot. So I think there was I saw an article that there was a startup in California with a fleet of robots delivering pizzas, and they are actually teleoperated.
Okay.
By humans. So it's the humans driving. So the robots the machines are not fully autonomous. If I hope I'm wrong. I think I'm correct, but I read those. But I was thinking, imagine if you had like a sort of a company that is teleoperating robots to act physically on the world, not just to navigate like with arms and stuff. Imagine if they had the necessity of having haptic feedback. The cost of deploying this solution would be gigantic, like 100K for each operator, just for having dual arm haptic feedback.
Yeah.
So it's in that sense, it's I think it's also like a challenge for HMI, like for those that are producing human-machine interface, to have something affordable and also like, but also like informating and performing as if you had the full setup, the full lab setup. And it cannot scale otherwise. It's too expensive.
But think about the opportunities. We should also bring the opportunities to companies. So we should talk much more with the industrial world. So because right now in this smart working setting, we only do office work at home. But think about having a couple of robots that can be teleoperated in the workshop. So you can really do smart physical working. And it's something that, well, the technology is there, but it's not been implemented. So I think that as roboticists, as a community, we have the capabilities of implementing such a thing.
There will be other pandemics, so maybe we have to
hopefully not. Hopefully not. Hopefully not. Who knows? Yes.
Who knows? Nature is nature.
Yeah, what I don't hope is that now we're gonna have the DARPA Robotics Challenge in pandemic style, and we are always after the disaster. Okay, that we do not understand that it's not a vertical problem, it's an horizontal problem. So there are some fundamental things that we're doing wrong. Okay, at the methodological level. Okay, not at the application level. When we put the blocks together, they don't work. And there is a reason for that. We have to find it out. Okay. So.
Yeah, for me, like criticizing a bit, like also being provocative, also this system of funding through projects or with small projects at the end is really not helpful, because it's difficult. Sometimes you have a small project with different application, and it's difficult to transfer and go like really solve the problem until the end. And then you have students that have to publish, but so you publish something incremental. It's not really like solving a problem. Like, I want to solve this problem.
Yeah, I mean, I hope that, I'm not gonna get a project anymore if I say something, but I mean, a responsibility of this is also on who gives money. There's nothing to do. Okay, we have to also, if so far we are doing something wrong, and who gives money keeps giving money to probably the same people or the same that keeps doing things in the same way. So clearly it's a shared responsibility, but it's also on the source side.
This is a call of funding. Please fund Daniele's lab. Like, please fund me. I will solve.
No. This is also, I have to say, I honestly say that as a lab, we are not a poor lab. There are realities that struggle much more than what we do. So absolutely. And I was thinking about them. Okay. That could somehow be a little bit disruptive in the methodology. Instead, these people then tend to align. Okay, tend to line up.
But there is so now maybe we are a bit out of scope, but there is a reflection that I've heard in many scientific discussion with colleagues about like the physics system. So in physics, you have the CERN, you have one big, for example, accelerator, and all the teams go to this big accelerator they share the same big equipment for doing research. And I think in robotics, they have tried to do the same with the Terinet, with other networks, like at European level, to share the same platforms. But it's so complex, and it requires so many engineers, so much more sharing and maybe standardization, or I don't know. I would honestly, in my experience, it's very difficult to say, oh, I need 2 weeks of, I don't know, your robot. I just come for 2 weeks and my paper is done because I just need 2 weeks. I have to transfer all my code into your code, and maybe your code has changed. So you don't have engineers to share, because you should have the engineers that are dedicated to work for everybody, not your engineers that share a bit of their time for other people. So it's a completely different organization.
Yeah. So probably, I don't know, we could envisage centers where we have standardized platforms, and the papers that get of category B and category A, if they run on certain standardized platforms, which certify the results and certifies also the reproducibility.
All right.
Then there's a lot of responsibility on the certifier. Who decides what's the hardware that should be used for certification or not? So it's not easy.
Yes, sure.
Yeah, it also changes a bit from the model of having labs in universities, where you have many universities, to one big center. So imagine if there was the CERN is the big center at European level. So imagine if you had just one big center at European level for robotics, where everybody's there, everybody's just concentrating all their efforts, but in one center. But it's a debate. It's an endless debate, because many people will say, yeah, but if you do this, then it's better to have a decentralized approach where you have more diversity than just focus in one. So there are many opinions on this. I've heard so far many opinions, and I don't know if there is one good answer. Okay, but maybe we're running a bit far, so maybe we can wrap up with go back to the main theme of the workshop. And so we can finish with the most classical question for all panel discussion. You have one answer to make, one simple answer. What is the most challenging theoretical or technological challenge in the shared autonomy field? Your biggest theoretical and technological challenge for shared autonomy.
I let the others start, or is it as you wish? Because I mean, in my opinion, the locomotion problem is an optimal control problem. And if you have it on the human, you have to run, and you want to predict the human, you have to basically run an NPC of an NPC. And somehow, I mean, in general, predicting the human in a theoretically sound way, and synthesizing control laws which are force-based, which means that you have to also add force sensors on the human in order to couple it with the robot. In our experience, is really challenging, because already if you put a couple of FT sensors on the shoes, things are going to be really complex to handle. So the entire infrastructure, so controlling the pair together with the aim of predicting the human motions and controlling the overall pair with a force control flavor is really complex also for the sensing issues. This is in our little experience.
Yeah, for me, there are a lot of big challenges. One of the main challenges is basically the name of the workshop, right? So learning and control, how to put together the flexibility of learning with the guarantees that control can provide, and by putting the human in the loop, so understanding what is best for the human, whatever it means, okay? In order to create a real synergy between the human and the robot, a real shared control, a real collaboration. This is the holy grail, in my opinion.
Yeah. I think two important topics that I had in mind were said. I can just add one more thing, which is choosing for the right level of variable autonomy, because in the spectrum of variable autonomy, you have full, let's say, human robot. It can be robot, or whatever. At one hand, you have fully manual. On one hand, you have fully autonomous. And there's a large spectrum in between. So choosing the right option would depend on the context, sensory systems, prediction of the humans, which is one of the hardest part, depending on how you blend the control and learning and how you expand your system to dynamics of interaction. So choosing the right level of variable autonomy for each task, embedded with the time steps, like if the fatigue comes, if the situation changes, how you can actually change that would be one of the biggest issues.
Yeah.
Everything is hard-coded at the moment. You decide who does what, and we don't have really good classical, let's say, a good approach to that, because we encode, we hard code saying that robot is good for this, human is good for that, but maybe this is not true for certain tasks, so we don't really know how to.
The problem is even harder. It's not a matter of hard coding. It's also a matter of, even if you know everything, you know perfectly the user, how do you design the variable autonomy? Because it's going to be variable also within a single job. So it's also theoretically complicated. It's not only a technological, which is also a technological problem, but also a theoretical problem. Yeah.
So there is another question, a question from Slack. So what would be your opinion on the usage of neural networks on a shared control context? For example, for learning shared control policies or for intention estimation. And the person that is asking, he says, I know that there are many people trying to bring neural networks to real robotics applications, but without much success due to their unpredictability and need of enormous data sets.
I think the question responds itself. Follow-up comment. Yes, if I can just quickly, I think the biggest problem we have is the availability of data, especially in interactive, let's say, tasks, because it's just, I see just neural networks, but if you need data in certain type of learning, I think that's the biggest problem, because we cannot put sensors everywhere. And most of the times, even behavior is not observable. So we don't really know how to then learn from the data.
I make a little bit of advertisement. In terms of data set, we released, I saw that Leonel Rozzo, in his presentation, he used our handy data sets. And he said that it was good. Yeah, so we're very happy. So it's tons of data. This data set, I mean, took really a lot of time from my team. And I mean, so it's 13 people that are recorded for more than 5 hours performing industrial motions reconstructed in the lab, but it's a lot of recording, and it has Xsense data, so it's motion tracking data, ground truth for external cameras, so it's but I agree with you that in this data set what is missing is the human-human interaction that we were planning to do and we couldn't do. It was already big to do this just with a human alone. And at that time, we didn't have the shoes, for example, which would have been necessary for collecting such a data set. We only had one pair.
Sorry, Serena.
So it's for another. It's for the continuation of the European project.
Yes.
No, but you need the shoes, but we also need the gloves or your box with the force torque sensor. But this only applies to collaborative carrying. if you want to record, so for me, this is another point that is, it's like putting force or tactile sensor everywhere on your body to measure, but also to perceive. So to have like bidirectional, like force feedback on what your teleoperating robot is feeling. I think this is very difficult.
Indeed.
But very cool. So
yeah, but it's very, very difficult.
Yes, for sensing, it's not an encoder. I put it that way. Yeah, you don't count ticks, unfortunately, and they work by sometimes changing shape, and which is already a weird concept, and there is a long way probably for the force control for sensing to improve. Let's say this.
Okay, I don't know if there are other questions. I don't think so. I'm having a look. I don't know if Mario and Marco want to add some things.
I'm fine. I mean, we discussed a lot of topics already. I think I'm very tired right now. So,
by the way, we still
Yeah.
have about 60 followers, so
Yeah.
it's a lot. It's an incredibly high number.
Yeah, the panel. So at level of informality, it looks like we're doing like an aperitivo.
Yeah.
Discussion over aperitivo. More than a panel discussion.
But I mean, at the end, the panel is between 6 Italians, because I mean, Arash is Italian by adoption. So I mean,
I'm also French by adoption. So
yeah. So you are like the invader from outside.
Yes, the invader.
No, I want to thank you like again for the for your participation, and also like to the speakers for remaining so late. I mean, it's starting to be like a bit late also, let's say in our time zone. I mean, it's 7 p.m.
Where are you?
I'm in Finland now.
Ah, okay.
So it's 1 hour later. There is one question that, can you please comment on using deep reinforcement learning in shared autonomy? So if you want to comment.
Deep reinforcement learning.
Yeah.
I think you chose wrong panel to ask this question.
Yeah, I mean,
we just missed Abderrahman Keddar to be perfect, you know, right?
Yeah.
Yeah, but deep reinforcement learning solves everything, we know.
It's a tool. In my opinion, the approach is that it is a tool. So you have to learn where you have to understand the screw for the screwdriver that you have. So it's a tool. You have to just apply it to the right problem. And this is
it's one of the many tools. It's one
of the many tools that it is useful for a certain category of problems. It's like, I don't know, you cannot use adaptive control for everything, because you know that you have instabilities of zero dynamics, or feedback linearization for everything, because you know that it's not robust with respect to uncertain parameters. So it's one of the tools that you have. You have to just find the right screw.
So the answer is why not?
Exactly.
Yeah.
And absolutely.
I think we just need to be careful about using the terminologies. If you remember a few years back, soft robotics was raising, and the discussion about soft robotics was everywhere. We had sessions of about soft robotics, and we knew that the problem will be payload, the problem will be the force production and things like that from the very beginning. And it took us a few years to understand, to go back to but we know the limitation of learning at the moment. We are pushing hard. This is really good. We had lots of beautiful tools coming out, like OpenPose, all these beautiful things that everybody's using now. But we know the limitations. So as everybody said, let's know what tool is matching what context. It's good to push it, but being so much, let's say, enthusiastic about this will bring, we have now the many learning people are warning to have this winter of learning, machine learning is coming and stuff like that, because we have so much expectation that we are not able to do as we expect. So it's also important to be steady but robust when we want to use these tools in real application.
Agreed.
No.
Let's do like in Scotland. Hi. When they say hi.
Okay, also from our side, thanks to the organizers, thanks to all the people that stayed so much late. It was a really great workshop. I myself enjoyed it a lot as well. And stay safe and stay
Thank
well.
you very much. And let's hope that we will have a physical one like next year.
Yeah.
Maybe.
Well,
Or next time with teleoperated robots that are representing ourselves. Daniele will fly and we'll crash all the other robots, like boom, with the super landing.
I hope not.
Everybody will be wearing Daniele's suit and teleoperating the robot.
Teleoperating the robot, yeah.
No, Daniele's bracelet. You said you wanted to
show. Yeah, sorry, the demo. I forgot. So yeah, these are the bracelets, and so this is one, so, and this is the other one. Now there is a demo effect, so probably they don't work. No, they work. So
and
you
so
see,
when they're closed, they vibrate.
They vibrate. So if I, it works. It stops, and
you have very long arms.
It's about 1 meter. This one.
Okay. And so you can tune this level of you can tune the distance.
Yes. So this is basically the node of I feel of the suit that then it's going to be integrated into the wearable sensors. So, but didn't exist 1 month and a half ago. So now we see what we will, if we are able to make something concrete with companies.
Good luck.
Okay. Thanks again for the organizers. I really enjoyed the workshop, and also a lot I have to say, the panel discussions. So I really liked it a lot.
It's a bit informal.
I liked it a lot.
Okay, thank you so much, and thank you for all the great talks. We will try to organize with Mario and Marco to cut the videos and put them online. I managed during one break to upload the video of Khatib, but it took more than 1 hour to prepare the editing with the iMovie, so I will do it, in the next days.
Okay, so bye and thank you again.
Thank you.
Bye-bye.
Bye, guys. Hope to see you soon.
Thank you. Bye.